Welcome to another video of linear algebra. In this video, we will discuss an exercise of linear transformation. And now let's see what. Now let's have a look on the exercise. So now let's look on the statement of the exercise. That is, now the statement is U is an invertible M cross M matrix, and a map is defined from T MMN to MMN, defined by T of x is equal to U of x, where for all x belong to MMN. Is T is a linear? We have to check out is T is a linear or it is a linear transformation. As we discussed in my previous video, that we have to check the two properties uh, for checking out that T is a linear transformation or not. And the other tricky one is that we just have to check that it is a bijective or not. If it is bijective, then T is a linear transformation. So we have to check it is 1, 1 and on 2. Now let's start the solution. And first we have to check it is 1, 1 or not. Now let's see. Now let's take, we have given that T of x is equal to U of x. And now for 1, 1, to check the property of 1, 1, let's take T of x is equal to 0. U of x is equal to 0. Now we are given that U is an invertible M cross M matrix. So we can write U inverse into U of x because U is invertible. So U of x is equal to 0. So we put the value which is equal to U inverse into 0, which is equal to x is equal to 0. So this proves that T is a 1, 1. Now let's check the other property. Now we have to discuss it's the surjective property that is also called an onto. Here we have any element y belongs to M and N. So let's check is it surjective or not. T into U inverse of y is equal to U into U inverse of y. That is a surjectivity, means every image has a pre-image. So y is a subset of M into Mn. So y is onto. T is and T is a linear transformation. That is it is 1, 1 and onto. So T is a linear transformation.